Hey everyone, welcome back to Horse Patterns. In today's video, we're diving into a powerful design pattern that helps keep business logic clean, flexible, and reusable, the specification pattern. By the end of this video, you'll understand what the specification pattern is, how it improves business rule handling, why it's better than traditional approaches, and how to implement it in your own projects. Let's jump right in. What is the specification pattern? The specification pattern is a way to encapsulate business rules into reusable, composable objects. Instead of cluttering your domain objects or services with multiple conditions, you define clear and testable specifications that determine whether an object meets certain criteria. In simpler terms, it separates business logic from domain models. It allows flexible and reusable rule composition. It makes code more readable, testable, and maintainable. Why use the specification pattern? Let's say we're building a weightlifting competition system. We need to check whether an athlete qualifies for a specific event based on their performance in lifts like snatch and clean and jerk. A bad approach would be stuffing complex if-else conditions directly into our domain models. This makes the code harder to read and reduces flexibility when business rules change. Instead, the specification pattern offers a cleaner solution. It extracts these conditions into self-contained objects that can be combined dynamically. To understand this better, let's start with the simplest building block of the pattern, the atomic specifications, which check a single specific rule. Before checking if an athlete qualifies for a competition, we need to ensure their email is valid. This is where the specification pattern comes in. Instead of embedding validation logic directly inside the weightlifting class, we create a reusable email specification class. This method uses a regular expression to check if the email follows a valid format, making the rule separate, reusable, and testable. Now, inside our weightlifting class, we apply this specification. If the email doesn't match the rule, we throw an error, ensuring only valid emails get through. By isolating individual rules, like email validation, each rule remains independent and reusable. However, practical applications often require more than just single rule enforcement. To handle more complex business requirements, we can dynamically combine multiple specifications. This is where composite specifications come into play. Let's take it a step further. Each of these specifications represents a single qualification rule, one for the snatch lift, and one for the clean and jerk lift. But what if we need to check multiple conditions together? Instead of hard-coding if-else logic, we can combine specifications using logical operations like and, or, and not. Here, we use an and operation between our specifications. The athlete must meet both the snatch and clean and jerk weight requirements to qualify for the Olympics. This approach makes our business logic flexible and reusable. If qualification criteria change, we simply update our specifications without modifying the core domain model. Why the specification pattern matters. Better separation of concerns. Business rules are encapsulated, keeping domain models clean. Reusability. Specifications can be applied across multiple use cases without duplication. Flexibility. You can dynamically compose new rules without modifying core business logic. Improved testability. Each specification can be independently tested, making debugging easier. When to use the specification pattern? Your business logic is complex and frequently changes. You need to reuse rules across multiple parts of the application. You want to keep domain models lightweight and focused. You are following domain-driven design, DDD, principles. With the power of composite specifications, we can define flexible qualification criteria. Now, let's put this approach into action by testing composite specifications to see how they apply different rules and determine eligibility. In our tests, we check whether an athlete qualifies for the Olympics based on their lift performance. Here, we define a test case where the athlete lifts above the minimum weight requirements, ensuring they are eligible for the Olympics. But what if the lifts don't meet the minimum requirements? In this test, the weight is below the threshold, which should make the athlete ineligible for the Olympics. To sum it up, the specification pattern is an excellent way to manage complex business rules without cluttering your domain objects. It brings reusability, flexibility, and better maintainability to your codebase. Have you used the specification pattern in your projects? Let me know in the comments. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell for more awesome software design content. Thanks for watching, and I'll see you in the next one.